Okay, so this video is for those who are taking that retake on Tuesday. It'll only be like 5, 6 questions, nothing big. So you have one period, which is enough time to do it. So let's start this. Try to be a little bit slower today. Okay, so it's a percent question. Okay, so I'd like you to do or stick to the percent proportions. I think that would be simpler. Okay, so it's just a matter of finding where numbers go and trying to understand the problem. So here's your percent proportion. 100 goes here, percent goes on top. This would be part and total. Remember, a percent is a part to total ratio, right? So Mark spent 20% of his money on comic books. So 20%, okay, that will go here. If he had $150, how much did he spend on comic books? So we don't know the money that he didn't spend everything on comic books. He spent a part of it on comic books. So that's our mystery number. I'll put a question mark over here. And obviously, this part guy, this 150 is the total amount of money. So out of the 150, how much did he spend on comic books? And that's what we're trying to find out. And that we know as a percent is 20%, but we don't know in terms of money, the actual value. So let's find the relationship here, if there is one. So let's see. Up and down. Is there an up and down? There is an up and down. Let's just side to side. You know what? Let's do an up and down. If there is an up and down, that's obviously there. Why are we going to change to something else? So look up and down. How does 100 go to 20? We're going this way. We're going to go from this that we know to the part that we don't know, right? So how does 100 become 20? Divide by 5. So to go that direction, to the unknown direction, 150, we also going to have to divide by 5. And 100 divided by 5, 150 divided by 5 is 30. So there's our answer. That's the part of the 150 that he spends on comic books, which is $30. Okay. Change the following measurements to meters or to centimeters. To meters. So let's take care of the first one over here. We know that 1 meter is 100 centimeters. There's my proportion. On the other side, I'm going to write meters on top. Okay, centimeters at the bottom. What do we know? We know that's 148 centimeters, right? So we want to change this to meters. So we're going this way. There is a very simple relationship. How does 100 become 1? Divided by 100. So on this side, it's also going to be divided by 100. You're going to take 148. So in your calculator, you're actually going to put 148 divided by 100. Or if you're going to do it manually, you're going to put 148 like this and divide that by 100. Okay. Or you can know that divided by 100 also means that you're moving the decimal. There's a decimal place right here, 2 spaces to the left. Okay, which becomes 1.48. So regardless of whatever method you use, the answer is going to be 148 meters. Okay, so let's do the manual here. 100 goes into 148 one time. You have 48 left over. I'm going to add a decimal. I'm going to add a decimal and a 0. Bring that down. 100 goes into 480 4 times. That is 400. And then you have 80 left over. I'm going to bring another 0 down. And 100 goes into 800 8 times. There you see, I get the same answer, 148. So you can either move the decimal 2 over to the left, okay, as a little quick thing to do, or if you do it manual, you'll see that you'll get the same answer. So let's do one more. So again, the relationship you need is that 1 meter is the same thing as 100 centimeters. On this side, you're going to write meters and centimeters over here. So you have 74 centimeters each, which you want to change to meters. So again, this is divide by 100. And you're going to also divide by 100. So again, you have choices. So you're going to take 74 and you're going to divide it by 100. You're going to set it up like this, 74 divided by 100. So as we were talking in the previous problem, you know that dividing by 100 means move the decimal. So here's a 74. The decimal's at the end. It means moving the decimal 2 places over to the left. Okay, and that's your new decimal spot. So your answer becomes 0.74. You're moving from this to from this side all the way once, twice, and it ends up being 0.24, 0.74. I'm sorry, and just to put a placeholder in the front, you end up being 0.74. Okay. Okay. Linda reads 48 pages of her book, which represents 40% of the book. How many pages does the book have in total? Okay, so 100. This is going to go here. Percent always goes on top of the 100. This is part, this is total. 48 pages represents 40% of the book. It doesn't represent the total number of pages. So this is what we need. We need now, how many pages does the book have? So we don't know what the total is, but we know that 40%, if she read 40%, that means she read 48 pages. So let's find the total now. So let's see if there's a relationship. Look up and down first. Is there a way that, so we're going this way, okay? So we're going this way. We're going towards the unknown value. So we're going to go this way. Is there a way that 40 becomes 100? No. Okay, so now if that's not possible, let's look side to side. Is there a way of 40 becoming 48? No, but let's simplify it. Let's divide this by 10. If I divide that by 10, 40 divided by 10 is 4. If I divide 100 by 10, I get 10. So I'm no longer going to use this, but I'm going to use this reduced ratio. Now there's a relationship, is there? How does 4 become 48? Times 12. So here, how does a 10 become this unknown value? It's going to be times 12. And 10 times 12 is going to be 120. So how many pages does this book have? 120. Next to is of. So you can set it up like this. Okay, nothing changes. So it's just a different way of looking at the percent problem. So 35% of what number is 49? So 35%. So I'll go here. Of what number? Of what? We don't know of what. So the of is what we're going to leave empty. And the is 49. We know what the is. It's 49. It goes right here. Up and down, look. Is there a way of 35 becoming 100? No. If not, let's look side to side. No relationship there. So let's simplify. Anytime we don't have a relationship, we simplify. That always helps. So divide by 5 gives me 7. Divide by 5 gives me 20. Let's cross this out. Now, can you see if there's a relationship between 7 and 49? We're going that way. It's times 7. So 20, to become our mystery number, you're going to multiply times 7 as well. Gives you 140. Again, here, what percent? So what percent is saying? So you don't know the percent, so that's obviously our empty value here. Of 60, there's your value for of, which is over here. And obviously is 48, goes here. Up and down, nothing. Nothing multiplied by 48, or nothing divided by 60 gives me 48, so nothing there. So let's simplify this. Divide by 4, no, divide by 5, divide by 6, divide by 10. Let's divide this by 12. Okay, so this one's a little bit, so divide. So if I divide 48 by 12, 48 divided by 12, I get 4. If I divide 48 divided by 60, I'm sorry, 60. I'm dividing by 12, by the way, okay? 48 divided by 12 is 4, and 60 divided by 12 gives me 5. Good. Is there a relationship from 5 to 100? Yes. Times 20. So on top, it's going to be times 20, which is going to give me 80. The ratio of books to magazines is 9 to 11. What percent of reading materials are books? Okay, so again, set your proportions. 100%. 100% goes on top. Part to total. So we're talking about what percent are books. So how many books do we have? Well, 9 to 11. So 9 are books. So a ratio of 9 to 11 means that 9 are books and 11 are magazines. So imagine these on the table. In this particular group of reading materials, 9 are books, 11 are magazines. So 9 are books, and how many in total? Well, 9 plus 11 gives me 20 reading materials. So there's my part to total ratio. I want to find the percent. Well, let's see what 9 out of 20 is as a percent. We're going to change it. Times 5, right? 20 times 5 gives you 100. So this one, the 9 to become a percent, we're going to multiply by 5. Gives us 45%. So 45% of all the reading material in this group are made up of books. Okay. So notice that I've been setting a proportion, okay, over and over and over again for literally all the questions, I guess, till now. So again, here, Kim can type 45 words in 3 minutes. How many can she type in 10 minutes? Well, let's write it up. 45 words, 3 minutes. And we want to see how much she can run in 10 minutes. So how do we change this ratio so the denominator becomes 10? So is there a relationship from 3 to 10? Anything times 3 gives you 10. Don't do a decimal, 3.333, because that's a non-terminating decimal that goes on forever. It's not a decimal that ends, so don't use that relationship. Find a different way. Always look up and down. Is there something times 3 that gives you 45? There is. Times 15. So this, to give us our number on top, will also be times 15. And 10 times 15 gives you 150. So in 3 minutes, she can type 45 words, or in 10 minutes, she can type 150 words. What's longer, 48 feet, 48 feet or 18 yards? Well, you either change everything to yards or you change everything to feet. Make your decision. So I'm going to keep the feet and I change the yards. So I know that 1 yard is 3 feet, right? That's the ratio I know. So over here, I'm going to write yard on top and feet. So what do I have? I have 48 feet. Let's change that to yards. Side to side is the relationship. 3 times what's 48? There is. It's 16. So look at that. 1 times 16 will give you the number of yards here. So 6 yards. So 48 feet is the same thing as 16 yards. So, 18 yards. Wait, what am I doing? I'm changing the feet. Okay, so 48 feet in yards is the same thing as 16 yards. So I have 16 yards over here and have 18 yards, which is longer, of course, the 18 yards. So 48 feet is a little bit shorter than 18 yards. It takes Linda the squirrel 10 minutes, so let's write 10 minutes to run 5 blocks. Okay, there's your relationship. 10 minutes, 5 blocks. How many blocks can she run? 3.5 hours. Wow, that's a long run. So again, we'll write minutes on top, blocks at the bottom, keep that the same. Okay. So the number of blocks is going to be empty because I don't know. And I can't write 3.5 here because that says minutes and this is given in hours. So you need to change that. 3.5 hours, 2 minutes. So 1 hour, 60 minutes. Second hour is another 60. Another hour, 60. And 0.5 means half of an hour. Okay, so 0.5 an hour, it means the same thing as 30 minutes because that's what half of an hour is. So if I add all this up, I get 0, 6, 18, 200. That's 210 minutes. So 3.5 hours, the same thing as 210 minutes. Okay. Is the relationship to 10 to become 21 if you look this way? Yeah, times 21. So this one will be times 21 as well. And that gives us 105 blocks. So it's going to take the squirrel, not take, but he's going to run 105 blocks in 210 minutes or 3.5 hours. Okay. Again, I'm going to set another proportion. This one's a percent proportion. Okay, 100% goes here. Part total. 15% of the cupcakes that Carrie made are blueberry. So here's my 15%. There are 9 blueberry cupcakes. How many cupcakes did she make there? I know that 15% is how many cupcakes? How many blueberry cupcakes? It's 9. Okay, so 15% of the cupcakes that she made are blueberry. You can either say 15% or 9 in terms of the quantity here. Okay, so part of the cupcakes that she made is 9. Let's find out how many she made in total. Let's Let's find out if there's a relationship. Is there one? Side to side? No. If I divide by 5, let's see. If I divide this by 5, 15 divided by 5, I get 3. 100 divided by 5, I get 20. Okay, so we're going this way, right? Because 20 has to go this way to find its number. 3 times what's 9? It's times 3. So at the bottom it's going to be 20 times 3, and that gives us 60. So out of all the cupcakes that Carrie made this particular day, of the 60 total, 9 of them, sorry, 9 that were blueberry, which meant that she made 60. Okay. All right, hang on a second. All right, sorry. In a class of 80 students, 40 are for Japanese, half are Chinese. How many are neither Chinese or Japanese? Okay, you have to understand what half is here. Okay, so 40% of the class Japanese. 40 doesn't mean 40 students, mean a certain part of the class Japanese. So let me write that down. Japanese. Okay. Half are Chinese. Another way of saying half in terms of percent. You can say 50% of the class are Chinese. So there we go, 50% of the class are Chinese. All right, so that gives us a total of 90% of the class are Japanese or Chinese. How much does that leave us that is not Japanese or Chinese? Well, it's a percentage out of 100, right? So here's 100% of the class. Let's take the 90%. That leaves us with 10% of the class that is of some other background. That's what we need to find. So let's set a percent proportion. 100%. 10% is what we're interested in. I care about students that are not Japanese or Chinese, which is this 10%. Let's find out how many. Okay, so 10% of the class are not Japanese or not Chinese. Part total, and total number of students is 80. So let's find out how many kids that would be. Is there a relationship side to side here? No, but I can simplify this. Divide 10 by 10 gives me 1. I divide 100 by 10 gives me 10. There's my new ratio. Let me use that. Is there a relationship to 80 now? Yes, times 8. And this would be times 8. So it gives me 8. So out of the 80 students, 8 students, or 10% of the class, are not Chinese or Japanese. Okay. Okay, so let's move on. In a survey of 500 students, 25 like science, 25%, I'm sorry, like science, 40% like English, 10% like math, 25% like social studies. How many do not like English? So we want to find a number. So let's find the percent first that don't like English. People who don't like English are these guys, these guys, these guys. Those are the people who don't like English. They like science instead, math and social studies. So let's add them up to 25% science. Here's a 10% of the math people. And here's a 25% I like social studies. So as far as percent goes, let's add this up. This is 10 goes 1, 2, 3, 4, 5, 6. 60% of the kids here. 60% of the kids don't like English. Okay, they like something else. And that's the group of people I want to find out. I know as a percent out of 100, it's 60% of them. But I don't know how many students. What's the number of students? Let's find it out. So percent proportion again. 100 goes here. Percent goes up top, and the percent that we're worried about here is 60%. These are the percent of the students that do not like English. Part total. How many kids we have? 500. So that's going to go over here. Number on top will be the part that represents the 60%. Times 5, times 5 as well. That gives us 300, and that's your answer. 300 kids do not like English. Okay, they like out of the 300, some of them like English. Out of the 300, some of them like math, and out of the 300, some of them like social studies. Okay. Put the following in order from least to greatest. Okay, so like I said, you can change everything to centimeters. You can change everything to meters. Let's see what I have. I have 1, 2, 3 meters and 2 centimeters. I'm gonna change this guy to meters. I'm gonna change this guy to meters. Okay. So 95 centimeters. Remember from the problems that we did before, change it to meters will be the same thing as moving the decimal to the left 2 times. So here's 95. There is no decimal, but there's one right here. We'll move it 1 to the left. It's going to become 0.95. Okay. So it's going to become 0.95 meters. This is going to become, again, 108, so I'm just put it on top, 108 centimeters. So I'm going to move the decimal 1 to the left, and that's going to give us 1.08 meters. So now I have all my numbers in meters. I can actually compare. So let me write it down. So one is 0.7. The other one is 0.95. Third one is 1.3. Fourth one is 1.08. And the last one is 0.93. To make life easier, I'm going to add 0 here and a 0 here so that everybody has the same number of decimal places. So we want from least to greatest. What the least smallest number? You can even look at this and pretend it's money for a second. This is the smallest one is 0.7. Second smallest one is 0.93. Next one comes 0.95. After that becomes 1.08. And the last one is 1.30. There's your order from least to greatest. Last question, I think. Yeah. What percent of the following words in the word percentage are vowels? Okay, so let's count. So the word percentage has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters. 1, 2, 3, 4, 5, 6, 7. There are 10 letters and 10 total letters. And how many are vowels? Well, the E, the other E, the A, and the total. 4 vowels. I want to change this to a percent, right? So let's get this. 100%. Percent goes on top. Part total. So what do we care about? The vowels. How many vowels do we have? 4. Out of total, how many letters? 10. So 4 out of 10 are vowels. So let's change the percent either way. This was a little simple. We're going this way, right? Times 10. And top is times 10. Which gives us 40 times 10 is 4. 40% of this group of letters are vowels. Okay? Okay, so hopefully that helped a little bit.